So the next thing that we want to look at is, are there extra electrons that we need to put into the structure? So if the answer is yes, we need to, actually this box should be an arrow, we need to put them in pairs around the central atom. If the answer is no, if an atom has an incomplete octet or does not have 8 electrons, we need to look to use double and triple bonds. So let's look at the CF4 that we just drew. The carbon surrounded by the 4 peripheral atoms of fluorine. We have single bonds connecting the carbon to the fluorines, and we're going to fill in the octets here as we did before. So we said in this structure, you may remember earlier, that this structure should have a total of 32 electrons, because we knew that the carbon had 4 and each fluorine had 7 to get a total of 28. So altogether there should be 32 in the structure. So if we count up the total number of electrons, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So there are 32 electrons in the structure. And now let's take away the numbers so that it's not quite so crowded. And we can ensure that each atom is stable with 8 valence electrons. We accidentally erased one there. So if we look at this fluorine, it has 8 electrons. It has what are known as lone pairs. It has 3 lone pairs, so a lone pair is 2 electrons, and then it has a bond, which represents 2 electrons. This fluorine also has 8 electrons, as does this fluorine and this one. And the carbon, which is the central atom, also has 8 electrons, so it is stable as well. Let's erase this to continue on. For some reason, this isn't going to erase, so we'll create, thinking about still this same rule. And let's draw the Lewis structure for carbon dioxide, or CO2. So if we follow the rules that we laid out before, first we want to find the total number of valence electrons in the structure. So carbon has 4, and each oxygen has 6. So since there are 2 oxygens, we need to have 12 valence electrons to the oxygen. So we need to have a total of 16 valence electrons for the carbon dioxide. We want to put the central atom in the middle. So the carbon is going to be the central one, and then the oxygens on the outside as the peripheral atoms. And the next step is to connect the peripheral atoms to the central atoms using bonds. And then we need to fill in the octets of the peripheral atoms. So now we've filled in the octets, and now let's look at the stability of each atom and the total number of electrons. First, we can count the total number of electrons. There are 2, 4, 6, 8, 10, 12, 14, 16. So at first glance, this looks pretty good because we know we need to have 16 electrons in the structure, and we do have 16 electrons. But on closer inspection, it's not so good. This oxygen here has a total of 8 valence electrons, so that's good. And this oxygen here also has 8 electrons. But the carbon, however, only has 4 valence electrons, so that's no good. So let me take away some of the busyness here. And let's see what we could possibly do in order to fix this and make it better. So if we go back to our step from the slide before, we don't have extra electrons that we need to put into the structure, but the carbon isn't stable, so we need to do something in order to make the carbon have more electrons. And we can't just add excess electrons on, because then we would have more than 16. So we need to think about what would happen if we moved over this pair of electrons and made it into a double bond. The way that would look like this. So that pair of electrons would come over and it would turn into a double bond. So now the carbon is double bonded to the oxygen. So we haven't gained or lost any electrons in the structure, we've just rearranged them. And now if we look at the central carbon, we see that the central carbon has 6 electrons, so it's getting closer. And the oxygen on the right-hand side, this oxygen, it still has 8 electrons. It has 2, 4, 6, 8. So all we need to do now is move over another pair from the other oxygen. So getting rid of some of the junk here to make it easier to see. We can move over that pair and make another double bond to the carbon. So now the structure has 16 electrons in it still. Each oxygen has 8, and the central carbon also has 8. We also tend to draw this, we might tend to draw this symmetrically. So we would move over these electrons maybe to the bottom of the oxygen and redraw the structure looking something like this, just so that it's symmetrical. And if you don't choose to take this last step, that's okay too. The last rule that we're going to talk about for drawing Lewis structures is if you're drawing a Lewis structure for an ion, you have to add or subtract from the total number of electrons. Also, you want to add brackets around the structure and put the charge of the ion outside of the brackets. So, for example, if we're talking about the ion Br3-, we know that each bromine has 7 valence electrons, and since there are 3 of them, there will be 21 total. And since there's an overall charge of -1, that means we need to add 1 additional electron to the structure. So because of the -1 charge, we have to add an additional electron, bringing us to a total of 22 electrons in the structure. So we would arrange these with a central atom and the peripheral atoms, since they're all bromines. Doesn't really matter which one is central. We would put bonds in between, and we would complete the octets of the peripheral atoms. So if we look at this structure, we have a total of 2, 4, 6, 8, 10, 12, 14, 16 electrons. So if you look back at the rule from the last page, we see that there are extra electrons that need to be placed. We still need to put in 6 more electrons. So we're going to put them around the central atom in pairs like this. Now let's check to look at the stability of each of the atoms. This bromine has 8 electrons, so it's stable. This bromine has 8 electrons, so it's stable. And the middle bromine has more than 8 electrons. In fact, it has 10 electrons, which is okay because a couple of slides ago we saw that if an atom was in the 3rd period or below, it was possible for it to have more than 8 valence electrons because the size of those atoms is so large. So this structure is complete, except that since it's an ion, we need to put it in brackets and put the charge of the ion outside.